Here we have a SAT math problem. Okay, let's go to the question. A piece of iron rod costs $60. If the rod was 2 meters shorter and each meter costs $1 more, the cost would remain unchanged. What is the length of the rod? Okay, so what I'm going to do is I'm going to draw an horizontal line which represents the length of the original rod. So, and also let me draw another line which represents the rod which is 2 meters shorter. Okay, so our aim is to find the length of the rod. Length of the rod means the length of the original rod. So let me assume x as the length of the original rod. Okay, what is the length of this rod? Actually, this rod is 2 meters shorter than the original rod. So to get the length of this rod, we have to subtract 2 from the length of the original rod, that is x negative 2. And also we have the cost of the original rod, that is $60. Let me write over here. And also the information says even if the rod is 2 meters shorter, the cost would remain unchanged. So that is whatever cost we have for the original rod, the same cost we have for the rod which is 2 meters shorter. So the cost of this smaller rod also will be $60. Okay, now we know that the length of the original rod, that is x meters, and its cost is $60. So what is the cost of each meter of the original rod? For that, we have to divide the total cost 60 by the number of meters of length, that is x. So or simply we can write as 60 divided by x. This is the cost of each meter of the original rod. What is the cost of each meter of the rod which is 2 meters shorter? The same thing, we have to divide the total cost 60 by the number of meters of length we have, that is x negative 2. Okay, now I got the cost of each meter of the original rod and each meter of the rod which is 2 meters shorter. Okay, here when we compare these two values, which one is greater? According to the information, if the rod was 2 meters shorter, each meter costs $1 more. That is, the value of this one is 1 more than this 60 over x, because this is the cost of each meter of the rod which is 2 meters shorter. So it will its cost will be $1 more than this one. Okay, let me write both the stuff, that is 60 over x negative 2, and here we have 60 over x. Okay, so according to the discussion we have done so far, let me assume the cost of each meter, I mean the cost of this value is $3. Then what will be the cost of this one? So already we know that this is 1 more than this one. So this one, the value of this one is $3 and the value of this one has to be $4. If I want to balance this one and this one, either I have to subtract 1 from this one or I have to add 1 to this one. If I add the 1 to this one, then here we have $4 on the left side, on the right side also we have $4. The equation is balanced. The same thing, if I want to equate these two, either I have to subtract 1 from this one or I have to add 1 to this one, because this is 1 more than this. Okay, let me add 1 to this one to balance the equation. So now 60 over x negative 2 and 60 over x positive, both of them are equal. In this equation, we have to solve for x, which represents the length of the rod. So that's what we have to find according to the question. Okay, so let me write the stuff on the left side as it is. It is 60 over x minus 2. Now, to add this fraction and an integer, I have to multiply the integer by the denominator of the fraction. Once I'm done with this multiplication, I can take this x as a common denominator. So 60 positive 1 times x is just x. And now we can take this x as a common denominator. Okay, now what we can do is we can do cross multiplication. So when I do cross multiplication, the numerator 60 has to be multiplied by this denominator, then I'm getting 60x. And this numerator has to be multiplied by this denominator, then I'm getting x negative 2 times 60 positive x. Okay, now we can keep this 60x as it is. Now we can multiply these two binomials using the FOIL method. That is, let's multiply the first terms. X times 60 is 60x. When I multiply the outer terms x and positive x, I'm getting positive x square. Now let me multiply the inner terms. Negative 2 times 60 is negative 120. Let me multiply the last terms. Negative 2 positive x, I'm getting negative 2x. Okay, let me subtract 60x from both sides, because I find 60x on both sides of this equation. So if I subtract 60x from both sides, is positive 60x, negative 6x will cancel out. I'm just getting 0 on the left side. This one also will cancel out. I'm getting x square. We can write the x term next, that is negative 2x. Negative 120. Now let me write the same quadratic equation over here. This time I'm going to take this 0 on the right side. Then I'm getting x squared negative 2x negative 120 equals to 0. Actually, we have this quadratic equation standard form. That is, we have everything on the left side, and also the terms are written in order. On the right side, we have 0. Okay, now let's try to solve this quadratic equation by factoring. For that, we have to multiply the constant term negative 120 by the coefficient of x square. In this case, it's 1. When I multiply this negative 120 by this 1, I am getting negative 120. Now I have to get two factors over here, so that the product of the two factors equals to negative 120. And when I add these two factors, it must be equal to the coefficient of x, that is negative 2. I think negative 12 and positive 10 will work. When I multiply negative 12 and negative 12 and positive 10, I'm getting negative 120. When I combine them, I'm getting negative 2, which is a coefficient of x. Okay, now what I have to do is I have to divide both these factors by the coefficient of x, that is 1. Even when I divide them by 1, still I'm getting negative 12 and positive 10. Okay, so here solving this quadratic equation, not only this quadratic equation, usually when we solve a quadratic equation, we'll be getting two values, two solutions. Okay, the first solution, that is the first value of x. To get the first value of x, we have to change the sign of the first factor over here. It's already negative. If I change the sign, it will be positive. Now to get the second value of x, I have to change the sign of the second factor. It's already positive. If I change the sign, it will be negative 10. Okay, x represents the length of the original rod. The length of the rod can now be a negative value, so we can reject this one because negative 10 cannot be the length of the rod. So we can accept this one. So that is the length of the original rod is 12, that is 12 meters.